Good morning, everyone. Are you all here to learn something about grade and slope? So am I. But no, I'm joking, but I'm not joking because I really want this to be interactive too. So I'm going to go through a bunch of technical stuff here, and I would love any input anybody has as I go through some of this as well. So just throwing that out there. I think that's still one of the best ways we learn is through each other's experiences and all that stuff. So I'm going to show, and I always like to kind of kick off on a technical training like this too. I'm not here to tell you how to pave or how to pave grade and slope, but I just would like to share what I've seen over the years, and not only that, I want to give you a basic understanding for what it is and what it means when we get to paving in the field. So how many people would say you're fairly familiar with grade and slope when it comes to design or running the equipment? So yeah, so we definitely got people that know that stuff. How many is it kind of a new topic? Don't be shy. Yeah, okay. So hopefully I'll keep you all engaged, but kick off, what is grade and slope? So when we talk about grade, really with the paver and the asphalt, talking about thickness, right? How thick is that mat we're putting down? You could have the longitudinal grade or profile as well. And then when we talk about slope, or specifically cross slope, that's the percent crossfall in the mat or the road that we're building. So again, looking at grade, for what I'm talking today, it's thickness. So again, how do we get the thickness we want? And I'll talk about some different situations or different conditions and some of the equipment limitations and try to bring design into it and try to bring all those things together. But what's that guy doing there? It's measuring the thickness of the mat after they've paved it. So when we talk about slope or crossfall in the mat, again, that's just our percent crossfall. Typically, on a typical spec on a highway is what? From center line to the outside edge, probably 2%, right? In a lot of areas, unless we're going through super elevations and things like that. So that's grade, that's slope. Anybody still using a slope board like this guy's got in the picture here? They're kind of gone out of style. Everybody's using a smart level nowadays pretty much. But slope board, 8-footer, 10-footer, great tool, great way of measuring. No batteries required, by the way. So what is slope? It's rise over run, right? So we look at that, we've got a certain thickness or the rise there. And then in this example, we've got a 12-foot wide lane, and we've got that slope or that crossfall. So rise over run. In this calculation, it's just 3 inches, divided it by 12 there to get it in feet. Divided by 12 gives me 2%. So that's just the basic calculation when it comes to calculating slope. The easier way is there's slope charts out there like the one you see here. Gives you a lane width, and it tells you, how much drop you should have across that 12 feet, for example. The little formula's there, but it's 1/8 of an inch drop per foot horizontally is going to give me 1% slope. So you can just do the calculations from there based on your lane width, right? So 1/8 of an inch per foot is 1%. So across 12 feet at 1% slope, I'm going to have what, 1.5 inch drop? So from here out to the shoulder, 1.5 inch lower. If it was 2%, it'd be 3 inches lower at 12 feet, right? If it's at 8 feet, it's going to be 1 inch drop. So 1/8 of an inch per foot. Why do we care about it? Safety is a big one. So whether it's grade, that's longitudinal profile, we're looking at sight distances and things like that, right? So when the designers are doing the geometric design, ride and smoothness, that's what the public, our owners, care about the most. They want it to ride nice. And then the cross slope, again, is safety, again, right? So we got super elevations. You ever been on those roads where you got no super elevation? You go around a curve or something like that, and what's going to happen? You're going to slide off the road there on a day like this with the rain and that, right? And drainage, get that water off the surface. So this is just kind of my high-level general approach when it comes to looking at grade and slope. Obviously, you got to know your spec. So what slope should I be at a particular station or point on the job? Measuring the existing cross slope. So I put my days of a contractor hat on when I was with the paving crews and that, and we were not always the best, to be honest, at getting ahead of paving and checking the existing slope before we got to it, right? So that's something is really going to pay dividends, getting ahead of that, knowing what you have coming up. It's going to save a lot of headache, a lot of headbutting, you know, when you're got 5, 10 trucks lined up and now you're trying to figure out, you know, how are we going to pave this and keep the right thickness and all that. And that goes to number 3, which is really the planning part, right? So we got to get a bit of information ahead of time, know what the spec is, know what we're paving on top of, and then, of course, the obvious, communicate that plan, right? It is a teamwork thing. So when we look at the equipment, depending on whether it's new construction, mill and fill, overlay, we've got all kinds of different equipment that could be involved in getting that initial grade and cross slope. And I'm going to focus today on the paver. A little bit of honorable mention with the milling machine or the cold planer and the rollers. So even those rollers can change our slope, right? We pave it at 2%, and then maybe it was thicker out here and thinner here. And is it 2% after we roll it? No, right? Because that thicker section compacts more. So that's, again, another thing we just need to keep in mind when it comes to that planning part. So when we look at a paver, this is maybe very basic for a lot of you, but I wanted to go over it. You've got 2 components. You've got the tractor, which is what's pulling the screed at the toe point there in the green circle. So it's connected, the screed's connected by a tow arm to the tractor. Tractor receives the mix comes back on the conveyors to the screed, goes underneath, gives us our final grade and slope behind that screed. That screed, if I just take it off the tractor there, that screed is free floating. So what's the only thing holding that screed up when I'm paving? The material underneath, right? Exactly, right? It's that mix going underneath it. So, and I'll come back to it a bit, but that head of material or that amount of mix in front of that screed is going to affect how that screed rides and what our final grade and slope comes out as. So when we look at the equipment, I got 4 guys underneath that screed taking a look at it. Probably shouldn't have him in there because he doesn't have a hard hat on, but I don't think that's going to help if something bad happens. But don't get under a screed unless you've got it blocked, right? Safety, which these guys do. But screeds, the larger, the highway size machines come basically in two widths, doesn't matter what manufacturer, they're 8-foot or 10-foot main screed. And then you've got your extensions on each side, so those nice shiny chrome tubes there, that's your screed extension. So you got a fixed 8 or 10-foot center section, and then the extensions that slide in and out to various widths. So this is just one example. Again, but really what I wanted to show you here is you've got that fixed main screed, if you will, that's 8 or 10 feet wide. And then those extensions that can move in and out. We can also put slope in those extensions. So not only do they move in and out like this, they go like this, right? We can put slope in that extension. We can pull that extension in and put slope in it. So when it comes to planning and figuring out how we're gonna pave a job, we're looking at this sort of thing too, right? How wide are we gonna go with our extensions on each side? I mean, I've only got a 10-foot screed. Most of our paving's wider than that. If we're on a highway, it's 12 feet, maybe it's 17 feet, maybe it's 12 feet. Main line plus a 5-foot shoulder that we're paving at the same time. So there's your screed extensions, just knowing again that They've got different widths, and you can put slope in them. There's a picture just showing one, there's a job there. So they've got the main screed at 2%. That on the right side, that extension's out about a foot roughly. It's in line with the main screed, so now they've got that 2% all the way across from the right. And then on the far left, they put slope in that extension to get a shoulder break for drainage, right? That was in the design. So they're paving one pass, two different slopes there. You got the slope of the main screed and the right extension all lined up, and then another additional 2% for a total of 4 on that extension on the left. And you've got slope scales on the machines, so you can, if those are calibrated, hopefully they are, they're not always, you can use those as your guide to set up the slope. Then the other thing we've got with that 8 or 10 foot main screed is, even though it is fixed for the most part, it does have the ability to crown in the center. So the very center of that, we can hit the button on the paver and we can introduce positive crown. So that'd be like this, or negative crown, which would be an invert, depending on the model, but up to 5% is about max, I think. So it's not a lot, but you can have crown in the center of that screed, and that's what those guys in that picture are doing there. So they got right from the middle, it's actually draining to each side. So how do we adjust thickness and slope? So we're talking about cross slope, talking about thickness or grade. We can do it one of two ways. We can use the toe points, so we can move those toe points up and down to change our thickness, or move one side to change our slope, or we can use the depth screws or the cranks. Who all paver operator or screed operators use the toe points for making those adjustments? Anybody? Sure, yeah, there you go. So you can use the toe point, like I say, or you can use the depth cranks. And either way, again, will change your thickness. Now, just to give you the quick theory on that, or why that happens, that screed is set up, we take off from our joint, and we're paving it, should be paving at 1/4 to an eighth to a 1/4 inch, what we call angle of attack on that screed. So that gives us that little bit of nose up attitude, so that mix flows underneath and floats, if you will, supports that screed while we're paving. So we've got that angle of attack. When I raise the toe point, or toe points, left and right side, I increase that angle of attack. So what does that do as far as mix coming in? That's a lot more mix in, right? So what's that screed do? Whew. Go climbs, right? So I go to a new thickness if I raise my toe points while I'm paving, or if I go positive direction with the depth cranks. So I introduce an angle of attack, I let more mix under, I go to a higher thickness, a greater thickness. If I go the other way, it just does the opposite, right? I go from thicker to thinner. Now, if I do that on one side only, I don't do both sides. I just move one, or turn one depth crank on, let's say, on the left side or the right side. Now I'm paving like this, the thickness changes on the one side, right? So what does that change? It changes my thickness, but what else changes? Slope, right? Because now I'm thinner on one side than on the other. So now I've gone from, let's just say flat or 0. Now I've gone to 1 or 2 or 3%. So maybe 3 inches here and 1 inch here, for example. And if I change them both sides equally, toe points or depth cranks, that screed's just going to rise up. I'm going to be a new thickness, but I'm going to be at the same slope, right? So that's the big difference there. If I got one person on one side making changes but not the other, it's going to affect my slope in that mat. So what do we use most of the time now when we're paving highways, I hope? Because I'm a big proponent of automatics, right? Automatic grade and slope. So when we're paving manually, we're using the depth cranks, we're using toe points, whatever our preference is. But if we use automatic grade and slope, we've got sensors on on the paver. We've got a grade sensor and we've got a slope sensor, or a slope box we call it. And that measures the slope of the main screed. So automatics, all they're doing is, we've got a grade sensor reading off the grade, we've got a slope sensor that's constantly reading the slope of that main screed, and it's sending signals. If you can see my little pointer, that grade sensor in the bottom left, that grade sensor, the slope sensor is on the back on the screed. I got a picture of that coming up. But they're just measuring constantly as we're paving, sending a signal to the computer and telling which in turn tells those toe points where to go to maintain the slope we want and the thickness we want. So that's how the automatics work. They're not, I used to call it voodoo because I was around them for, I'd say it was probably 10, 15 years before I understood how they worked. So, confession. But you go in the display box, you can, once you bench it or survey it, you can control your thickness and slope fairly precisely. So there's a single grade sensor there on the side of the paver. All that grade sensor is a measuring tape. So when I've got automatics and I'm paving along, that thing's shooting sound waves down to the grade and they're coming back to that sensor and it's measuring that distance to the grade. And on the right there, that little video clip, the guy, his finger there, he's pressing and holding, he's going to get some green lights. So what that's done now is locked in that distance from the grade sensor to the ground or to the grade. Now as I'm moving forward, that grade sensor just tells Mr. Toe Point, 9.5 feet away, it tells him, it says go up or go down to keep me at that same 16, 17, 18 inches that I was off the ground when you surveyed me or benched. So that's how the grade sensor works. Where I position that sensor has a huge effect on the outcome. So I can place that sensor anywhere between that auger and that toe point, that single grade sensor, move it up or back, wherever I want it. And if I have it back at the auger, in line with the auger, that's where it's going to give me exact thickness. It's going to give me a perfect joint match. So if I'm matching a lane, I put that sensor back there, I'm going to match that lane right on, right? And it's because it's fast reacting. So think of that grade sensor back in line with the auger. That toe point cylinder that's going to move based on the grade sensor distance, it's 9.5 feet away. So if that grade sensor only has to move or sees a difference in height, right? It's just a measuring tape, sees a 1 inch change. Well, to get that sensor to move an inch, that toe point that's 9.5 feet away has got to do this, right? That's geometry. Like if I make so it's a big change is really my point here. So what's that do when I boost that toe point up? It's my angle of attack do. Big time, right? Bunch of mix comes under, what's the screed do? Climbs like crazy, right? Super quick. That's how it reacts fast, gives me that good joint match. Or again, if I'm paving, you ever get on the jobs where they just want you to put 2 inches on top of whatever you're on? They don't want any more because if it's more, you're paying for it, right? If it's less, you're getting penalized. Put your sensor back there. Is that going to make my ride any better though? No. I'm going to have the same ride, same smoothness as I had on that existing ground or grade. So that's back at the auger. There's a joint matching there. I've got that single grade sensor following along, quick reaction. Of course, they've got it up just a little bit. Why? Roller's got to come in and compact it, right? So they get a good joint match. I move that single sensor all the way up to the toe point. Now I'm going along. What's the sensor doing? Measuring tape, right? Measuring distance that I benched it at the beginning. So if that grade takes a little dip, now I'm 20 inches. What's it tell the toe point to do? Come down. But it's right at the toe point. So it's what we call a one-to-one reaction. It's going to move the toe point to get that sensor back to the same distance from the grade, but it doesn't have to move doesn't have to move very far, right, to get that sensor back to where it was. So you don't have a big change in angle of attack. So what you get here is a lot smoother ride. So it's still going to follow the grade, it's still going to maintain a thickness, but it's going to be a smoother change. So again, just depending where you put that single grade sensor makes a big difference. Slope control. There's my screed again, there's the 2 toe arms on there. All that slope measurement, slope boxes is a carpenter's level, right? Just a smart level or a carpenter's level, whatever, however you want to think of it. On a cross beam between the 2 toe arms. So it's measuring the cross slope of the main screed only, right? So it's just the main screed that's fixed. It's measuring that cross slope as we pave. The big thing here is when it comes to automatic grade control, if I got it locked in at 2% and it goes, the existing grade changes and it goes off 2, it's going to do what? It's going to tell one toe point to move, right, up or down to get it back to 2%, but it happens fast. So slope reacts quickly, not the best thing for smoothness when we get into using slope control. But why do we use it? We use it to correct profile, especially if we've got more than one lift to put in, get the base to the right slope with the slope sensor. Another thing, automatic slope control always follows the grade side. So I can't have slope, it's a fixed 8 or 10 foot screed, right? So it's one slope, whatever it is, 2%, 3%. So it references off the grade side. So I'm going to only run slope control on, say, the right side in this example. It's going to reference whatever that grade sensor thickness does on the left side and project 4% all the way across as I pave. So do you see how that slope side reacts quick? So if I'm paving and my thickness or my grade sensor on the left makes a change, that slope goes off, goes from 4 to 3%. It's just going to shoot up on the right side and get it back to 4 right away. So it's quick, right? And then you've got your sonic averaging ski, so we use those a lot on the highways for smoothness, right? And I'm not going to get into that too much, but we put that ski on. It's really just 3 grade sensors or 4 on that ski over 30 feet, or some skis are longer than that. And it's just averaging that number, sending the signal to the toe point to make a movement. And there's a setup there with the ski on the side there. These guys running the paver, they've got what we would call grade control on both sides. So on the left side and the right side, they're controlling grade with they've got a ski on both sides. Again, why is the ski on there? Smoothness, right? Am I going to get a good thickness reading or a good yield calculation at any one point when I'm running ski? Probably not, right? If I'm expecting to be right on tonnage-wise with that ski, because what's it doing? It's averaging over that 30 feet, telling the toe point to move. It's filling in the low spots, scalping off the high spots, and giving me that smooth road. Overall, the yield, tonnage should be close, but it may be off at any one point. So look at grade and cross slope. We've got kind of 3 different scenarios. One of them is new construction. Don't see a heck of a lot of that these days. But whenever we can, what do we want to do for the paving guys? We want to get that base right, to the right profile, right? To the right grade or the right slope. Because when's the paver do its best job? Making a smooth road. When it can run grade control on both sides, right? And we can avoid having to use that slope control. And again, slope control is there for a reason. I'm not poo-pooing it. But we're going to get a smoother ride if we can run grade control on both sides, or like you saw in the last one, ski on both sides. So if we got that profile already correct on the aggregate base, all we got to do is set up grade control on both sides of the paver, and boom, go. And we're going to be right on with our tonnage, right? So if we look at an existing road here, you've got, this is already 2 spec. So this is a road we're going to come in and do an overlay on it. But we've got a 12-foot lane on each side of the center line here, 2% each way from center. That's our existing. If I go in, I'm going to do a new construction over aggregate base. Again, I can just run grade control or skis on both sides of that paver on the base lift and the top lift, both. I'm going to get a super smooth road because I put that effort into getting good control on the aggregate base that I put down. So when we get into milling, probably most of our work, right? Mill and fill, I call it. So we go in, we mill it out, we come back, we pave it in. So we can get in a couple different situations there. In a perfect world, what do we want that milling machine to do? We want it to get our grade and our profile to the right slope before the paver gets there, right? Because that paver is going to, again, it's going to do its best job when it can run grade control on both sides, right? So, but a lot of times, what do? We come in, we got to do level course or scratch course to get that base at the right grade, and then we come in and maybe do a top lift. So there's a lot of different scenarios. Just one slide here on the mill. Just like that main screed on the paver, that drum on the mill, that's fixed, right? I can't bend it or do anything with it. So when I do grinding or milling, profile milling, that thing's going to be whatever width that drum is, all the way across at the same slope, right? So it's just something to keep in mind again. Like I say, in a perfect world, the mill gets the right profile or the right grade on our jobs. And we were guilty as heck. We had, where I used to work, we had subs come in all the time, did the milling. We didn't have our own milling crew. And we'd show up ready to pave, and unfortunately the base wasn't milled right. They're already long gone, right? So guess what? We got to fix it, right? You look at this is just another example, 12 feet wide, 2% crossfall there. We come in, we mill it out. So thinking about how specs line up with what we're doing on the job, right? So 12 feet wide, 2% the existing, that mill comes in. What did they tell them in the bid or the contract? They said take out 2 inches, take out 2, put back 2. So that mill comes in, uses grade control, takes out 2 inches there. Life is good, right? We can come back, we can pave that 2 inches back in at 2% because our grade was good to begin with, right? And then surface course maybe on top of that. So these are just examples. That mill cold planer, I think that one's older than I am, or pretty close. But it's using grade sensors on both sides to get that cross slope correct in the milling operation, right? So again, this goes back a little bit to the design or the bidding part of it, is you get those contracts that just say take out 2 inches and put 2 back, and then you get in the field, and what's the inspector want? Wants 2.5. He wants 2 inches and 2%, right? But it doesn't work that way if it's not that simple if we don't get it milled out properly. So now we gotta fix it. Now we're asking to do a bit of leveling course. What's that? Extra material, right? So now we gotta see who's gonna pay for more. So if I look at this milled surface, what do you see there? Just looking at that. Uneven. Does it look like it goes high there, doesn't it? Like kind of about midway in the picture, you can see a high spot. So that mill wasn't a consistent depth, went along, and for whatever reason, maybe that tie-in or driveway that's coming in there, but it went up higher, so we're gonna have a different thickness there, right? So now what's gonna happen when we get to paving it? High and low, right? We're gonna have a thin spot there. Either that or our mat's gonna do that, follow the grade, or we're gonna pave over it and be really thin there. Not good for compaction, durability, might even drag aggregate, drag rock if we get real thin. So, good practice here. What are these guys doing? They're checking the slope ahead of time so they know what they're coming into, right? If that slope isn't correct, where they're gonna take off here, what can we do with it? Kind of got our hands tied a little bit, don't we, on that situation. Might be able to level it, put a bit of level course in there. Probably not going to get the mill to come back there and do it unless you're catching them on the day they're there. But can create problems for us, right? And you want to check in multiple spots. So you're going to check that. That's the quality control. Do we do a good job on QC on checking our grade after milling? Okay, so it hasn't changed since I did it. Yeah, it's never, at least it never was that great, to be totally honest with you. They'll check the crap out of the pavement, the asphalt we're putting down, level all the time. Not necessarily with the milling part of it, or the aggregate base. So if we're doing aggregate base prep. So here they got two lifts. So they came in, milled it out, they're putting in the base lift. You can see a ski on the right side, so that's grade control, right? So they're putting that in at a I don't know what thickness they were here. On the left side, they've got slope control. So again, what's slope referencing? It's referencing the grade side, or that side the ski is on, right? The center line there. And it's building that slope or that profile at the 2% that they want. So that existing road was something different. They milled it out. Now they're putting the base lift in. The base lift's where you want to get the profile right, if you've got more than one lift to put in, right? And then top lift is just grade, ski, and nice and smooth. So if I'm checking thickness on this, which side am I going to check thickness on? Grade side, right? Because what's that slope side do? It just maintains 2%, right? So whatever the grade side does, that left side there is just going to go up or down to keep it at 2%. So the thickness on the slope side can vary quite a bit depending on the existing grade. So you're going to check thickness on the right side in that case. And that's all this is saying. Slope doesn't care about thickness, right? So we need that quality control really on that base that we're putting down. Another example, here's if we look at the existing asphalt, 12-foot wide lane, but what's the catch here? You look at that percent cross slope is 1%, right? What are most specs now? Probably always was. This probably was 2%. So 2%, right? So we got to fix this. So we're coming in to pave it. They want it 2% wide, or slope, I should say, after we pave it. So this is just an example where we may be coming in doing a leveling course, getting that 2% in there. It's going to come down to scratch at one point there. But now we come back in on the top lift, we can get our 2 inches and 2% all the way to that outside edge. Does that make sense? Geometry, math. So this is where we can run into problems, right? So it was 1%. Told the mill to come in and take out 2 inches. Is the milling guy going to take out more than 2 inches if that's what you ask him to take out? Costs more, right? More wear on the teeth, more material to get rid of, all that stuff, right? So, and I would do the same. I mean, if they're telling me take out 2 inches, I'm taking out 2 inches. But what was that existing profile? It was 1%, right? So how are we going to get this now to 2%? That's always the big question, right? I want 2 inches thick, but I want 2%. I do the math, my slope calculation there at the beginning. If I go from 2 inches at center thickness, and I go out at 2% now, 12 feet, I've only got half an inch of mix out there at that shoulder. That ain't going to cut it, right? Because I need more mix in there. So, I mean, there's options, right? I could come in, I could do that scratch or level course, get my grade right, and then come in and put 2 inches all the way across. But if that wasn't in the contract, or what's that add up to? A lot of money and material, right? So this goes back even to what a lot of the speakers this morning were talking about. It's really a team effort, right? It's not just the contractor. It's not just the owner of the road. It's everybody involved when it comes to planning this stuff. And there's your overlay. So this again, another way of doing it. I mean, it's going to be really thick there, right? Because they had a partial paved shoulder. They didn't mill out the shoulder, they only milled out the main line. Now you're like 3.5 inches to match that shoulder at 2%. Come back, put your top lift in. But what problem do you see going on here now? It's not uniform thickness all the way across, right? What do we have to do with that mix after we pave it? Compact it, right? We got to roll it. How much does that mix roll down? Quarter inch per inch, right? So in those thicker areas, it's going to roll down more. Am I going to have 2% all the way across? Probably, maybe. If I got a good roller operator that straddles that shoulder break there. Then we get into straight overlays, right? So that's just, we're just going out there, got the existing road, we're not milling it, we're not doing anything, we're just going to sit down and they just want us to pave over it, right? So it depends, again, what the existing is as to how we're going to get any change in grade. If we go out and just pave thickness, we're going to get the exact same thing we had, same profile, same slope, only at 2 inches of new mix on top of it, right? If we have to make corrections to the slope on a straight overlay like this with no milling or anything, what's really the only way I can do it? With mix, right? Asphalt mix. So I may have to be thick, and my whole point there is that just needs to be factored into the equation when those jobs are bid, right? So if I look at aggregate or common problems, again, just kind of a bit of a summary of what I covered here, but the aggregate base or the milled surface, can't overemphasize doing good quality control on that just to get that base correct, especially if that existing needs to be brought up to new standards or that 2%. And that's when we get into the battle, right? The owner wants the paving crew to correct it, but nobody wants to pay for the asphalt. So, and again, I'm just throwing these scenarios out there. Could be poor planning, just not doing that checking ahead, right? When are those conversations the easiest to have? Before, early, amen, brother, right? Because when you're out there and you got trucks lined up and everybody's under the gun, under pressure, it doesn't always go so well. And then the other big thing to think about again is that compaction. I keep mentioning it because people kind of tend to forget about it a little bit. When it comes to paving it in, we've got variable thickness, we're going to have variable compaction. So I may have to be a little thicker in an area so that when I actually roll it, now my profile, my slope all the way across is the same. Going to talk a little bit on super elevations. How many of y'all pave through super elevated areas? So you're coming along, you know, your main road, 2%, and you go into the super elevation, so it's doing what? It's increasing slope. At some point in the middle of that super elevation, you got to slope all the way across, maybe 6%. Again, what's that for? Keep cars from going into the ditch, right? At 60 miles an hour or when it starts to rain. And then what do you do after you get through that super elevated section? You come back down, right? Back down to your 2%. So sometimes those can be challenging. Again, big thing here is checking ahead, whether it's milled or milled surface, aggregate base, and then making note of any corrections that are necessary to that base before we get in there. Or having that discussion that, hey, we're going to have to use some more mix here to correct or get this final profile right going through this super. One thing, if you're checking ahead, here you can see these guys, they marked it out on pie plates for who? Screed operator, right? So he knows, if he can see that from a distance, he knows when he gets to that point, he should be at 1%, right? And you have those marked out every 25 or 50 feet going through that super elevation so that you can make sure you're on grade. And again, communication, right? Talking with the inspector, the owner. If you, as a contractor, see that, hey, I'm going to have to use a little more mix here to get this going through here at the 6%. Because what? I got slope out here, I got thickness. Again, if my base wasn't perfect, I'm going to be using more mix there. Or if it was too high, I'll be a little less. Doesn't seem like that happens too often. And then just choosing the setup that makes the most sense for going through super elevation, right? If, again, same as on the straightaway. If the profile is correct, I don't even need slope control. I just run grade control on both sides of the paver, thickness, right? Because my base is already good. Grade control on one side, automatic slope control on the other side. So when I got small changes or corrections, if you will, in slope going through that super, automatic slope control works great for doing that. If I've got big changes, my base is kind of all over the place, I would recommend just using manual slope control. You can use the depth cranks as you go through that super, but you got to know where you are, right, and where you're headed. So that goes back to the pie plates or paint marks, something that you can see on the screed and make those changes. So again, there grade control on both sides. If the base is correct, it's going to give you the best yield or quantity. It's going to give you the best ride. Those small corrections, again, grade control one side, automatic slope on the other side. Here they've got the ski, they just turn it off going through that super elevation, and use a grade sensor, and then slope control on the left side. One thing I like to do is we get into those larger corrections. Like I said, automatic slope changes fast. I want a smoother change, I can do it manually, right? Again, as long as I know where I am and what's coming up, I can manually change that slope and do it a lot smoother than that automatic can when it comes to slope control. The key is knowing what my slope is. You can use the display on your automatics. Doesn't matter what brand, they all have it. You can show that. So there's my actual slope number right there, even though don't have automatics engaged or turned on. So I can be on the screed watching that, turning the screw, and keeping that slope as I go through that super elevation. So it's just another way of doing it to get smooth changes, and that's what this guy here is doing. So, and then I mentioned the roll down, right? So again, about 1/4 inch per inch. So if I want 2 inches after compaction, how much loose do I put down? 2 1/4. 2.5, right? 2.5 inches loose. It's going to roll down to about 2 inches. And that's, again, when we're talking about cross slope, that's what I got to just be aware of, right? Because if I've got that green section there in the middle on the right, if that's my pavement and I'm at 2% and I come in and roll it, it's going to roll down more on that thicker edge, right, than it is on that. So what was 2% behind the paver now is the bottom green, it's 1.5% because it rolled down more on that thicker edge. So that's where you have to factor it in the paving part of it, your loose mix coming out behind the screed. So just to kind of summarize, to be successful with grade and slope, know your existing base conditions, right? So you got to check that stuff, guys. Like, get out there, check it, know what you got coming. Have any discussions if they're needed, on how you're going to pave it. So come up with your paving plan to meet that final grade and slope, and just make sure everybody's on the same page with it, right? And I know it sounds pretty basic, but it doesn't always happen, right? And then of course the final thing is actually got to execute it, right? So when we get on the job, we got to do what we said we're going to do to get that grade and slope where we want it. That's all I have. I could talk all day on like nitty gritty and get in on the paver settings and all that stuff, but high level grade and slope, any questions on that or any comments? I know I kind of blasted through pretty quick, but if it makes sense, you can call BS too, so if you don't have to agree with me. That's why I like the discussion. Okay, well, thank you everyone. Appreciate it.